Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to go over an example problem of limiting reactants. So let's get into this. First we have to review what a limiting reactant is. So the situation you have is you have two reactants. You're given two different amounts of reactants and you're asked, well, what is the maximum amount of product that can be formed given these amounts of the reactants, and that's all you're given. Well, normally, I shouldn't say normally, but in a lot of times, we're given problems where we're told that one reactant reacts completely with another reactant. So we know that at the end of the reaction, no reactant is left over. So they both react completely to form a certain product. In that case, we don't have a limiting reagent problem because both of them are equally the limiting reagent. You don't need to figure out which one is going to run out first. So, in a limiting reagent problem, one of them is going to run out before the other one. So, one's going to run out, while the other one you're going to have an excess amount left over. So think of it like making peanut butter and jelly sandwiches, right? So if I have a jar of peanut butter and a jar of jelly and some bread, I can make peanut butter jelly sandwiches until one of those ingredients runs out. So as I'm making the peanut butter and jelly sandwiches for the picnic that I'm going to go into, if I run out of bread before anything else, then the bread is the limiting reagent because I can't make any more sandwiches without the bread, right? The bread limits the number of sandwiches I can make, or I should say the amount of bread I have limits the number of sandwiches I can make because I ran out of bread first, right? Or if as I'm making my peanut butter and jelly sandwiches, I run out of peanut butter before anything else. So I have some leftover bread and I have leftover jelly. In that case, the peanut butter would be the limiting reagent because it's now limited how many sandwiches I can make because I ran out of that first and I have excess bread and excess jelly left over. So in this case and other limiting reagent cases, it's the exact same way. I'm given amounts of my reactants and I'm asked, well, how much of a certain product can I form? Well, in order to answer that question, you first have to figure out which one runs out first. Whichever one runs out first is the limiting reagent. There's a couple of ways that you can figure out what the limiting reagent is. One way is you can convert both of the reactants to moles if they haven't given you moles already, right? So if they give you a certain mass amounts of them, like grams of this, grams of that, or kilograms of this, or kilograms of that, you can convert both of the reactants to moles and then convert one of the reactants to the amount of moles of the other reactant to see how many moles of one reactant would you need to completely react with the other, right? So in that regard, you can figure out, well, do I have enough of the other reactant to react completely, or do I have, more than enough or less? So you can compare the reactants. That's one way. The second way is that you can take the two amounts of reactants and see which one gives you more product or less product, right? So remember, the limiting reagent is the reagent that runs out first, right? So if that one runs out first, then it's not going to produce as much product. So you can take both reactants, convert it to the product that you're interested in. So I can take grams of reactant A, convert that to grams of product. I can then take grams of reactant B, convert that to grams of the product. And then I can compare the grams of product produced by both hypothetically. The reactant that leads to the lesser amount of product is the limiting reagent because it limits the amount of product that can be formed to a smaller degree, to a smaller amount. So therefore, it's limiting the amount of product formed. I prefer to do it that way. I think it's clear cut way of figuring out what the limiting reactant is because it's tied to the amount of product you can actually form. So I'm going to show it that way. Okay, so here's an example problem. Sorry that was a long a long introduction. Oops. Sorry, that was a long introduction, but I think it was necessary to preface that before we get into the problem. So here is my balanced equation, and here's the question. What is the maximum mass of TIC, that's a product, that's our product here, that can be formed from the reaction of 985 kilograms of TiO2 with 500 kilograms of carbon? So notice here that they have given us two amounts of each of our reactants. We have two reactants. They're giving us an amount of one reactant and an amount of the other reactant, and they're asking, well, how much can be formed? Notice they don't say in here that one reactant completely reacts with the other one. So we have no idea. So this is a limiting reagent problem because we first need to figure out which one of these is the limiting reagent. Which one of them is going to run out first? Which one of these is going to produce less product? So we need to figure that out first. We can't assume that they're going to evenly, they're going to both completely react and we're not going to have any left over. Okay, so the first thing we want to do is convert both of these amounts to the TIC to figure out, well, how much TIC are they going to form? And we're going to do our mass to mass conversion, or you could stop at moles, because if you can compare the amount of moles, that's good enough as well. But sometimes your problem is asking for like a percent yield, or they want to know what the mass of it is. And so a lot of times there's a second follow-up question saying, well, how much is the amount? So in this case, they're asking us, what is the maximum mass? So we're going to convert both of these reactants to kilograms of the TIC, the product that is of interest. Okay, so we'll start with the 985, So we'll start with the 900, 985 kilograms of TiO2. Excuse me. So we're going to convert that to TIC, kilograms of TIC. So we're going to start with the kilograms. And again, we're going to follow our roadmap. Remember, when we're converting from one substance to the other, we have to get to moles. That's our goal, to get to moles. So we need to convert this to moles so we can use our mole ratio. So here I have kilograms. So I'm going to need to convert that to grams first. So that way I can use the molar mass of TiO to convert it to moles. So grams to kilograms, I know that 1 kilogram is equal to 1,000 grams. So I'm going to put 1 kilogram of TiO on the, that should be TiO2, sorry, on the bottom to cancel out here. And then I'm going to put 1,000 or 10 to the third grams of TiO2 on top. So kilograms cancels out. Now I have grams. Now I can convert this to moles using the molar mass of Ti2. And so if I calculate the number of moles, or the number of grams, the molar mass, so then the molar mass is 79,866. So 79.866 grams of TiO2 on the bottom to cancel out grams here. And then I'm going to put 1 mole of TiO2 on top. So grams of TiO2 cancel out. Now I have moles. Now I can use the molar mass to convert TiO2 to moles. So I can moles of Ti2 to moles of the TiC. So here I'm going to use the mole ratio in the given equation. So here I have 1 mole of TiO, so 1, and 1 of TiC. So it's a 1-to-1 ratio. So on the top I have TiO2, so this is going to be 1 mole of TiO2, and on the top 1 mole of that should be TiC. There you go. So moles of TiO2 cancel out. Now I have moles of TiC. And so now I can start to convert moles of TiC to mass. So I can convert it to grams and then kilograms of TiC. So the next conversion factor, again, is going to convert moles of TiC to mass of TiC in grams. Again, I'm going to use the molar mass. And if I look at the molar mass of TiC, it's going to be 59,878. So I'm going to have 59.878 grams of TiC on top, and then 1 mole of TiC on the bottom. Moles will cancel out, so there you go. Now I have grams of TiC. Now I can convert that to kilograms using the same relationship here. 1 kilogram is equal to 1,000 grams. So I'm going to go ahead and put that here. So grams is on top. I'm going to put 1,000 grams or 10 to the third grams of TiC on top, and then 1 kilogram of TiC. I think I said on top, on the bottom here, and then on top you're going to put 1 kilogram of TiC. So grams of TiC cancel out. Now I have kilograms of TiC, and so now I can calculate the amount of TiC formed from this amount of TiO2, assuming that this reacts completely. Okay, so when I calculate that out, I get 738 kilograms. So then this is going to be equal to 738 kilograms of TiC that is formed from this amount of TiO2. Okay, again, assuming that this reacts completely. Okay, so now we do the same thing with 500 kilograms of carbon. So I'm going to start with 500 kilograms of carbon, 500 kilograms of carbon over 1. And I'm going to do the exact same set of calculations. I'm going to convert kilograms. Again, I want to convert carbon into TiC. To do that, I need to go through the mole ratio. So again, whenever you're doing a mass-to-mass conversion, or really any conversion from one substance to another substance where you have a balanced equation, you're going to use the mole ratio. And so we're going to use the mole ratio. We have to convert moles of one substance to moles of the other. So same steps, but we're going to use a different molar mass. So to convert kilograms of carbon to grams, again, I'm going to have to use 1 kilogram is equal to 1,000 grams. So I'm going to put 1 kilogram of carbon on the bottom, 10 to the third grams of carbon on top. So kilograms is going to cancel out. Now that I have grams of carbon, I want to convert that to moles of carbon using the molar mass of carbon. So then I'm going to look up the molar mass of carbon. So we have 12.011. So the 12.011 grams of carbon is on the bottom to cancel out grams of carbon on top. And then 1 mole of carbon on top. So the grams of carbon cancel out. Now I have moles of carbon. Now I can use the mole ratio between carbon and TIC. So here I have 3 carbon and 1 TIC. So it's 3 to 1. So I'm going to use that mole ratio. So I have 1 mole of carbon on top. So I want moles of carbon on the bottom. That's going to be 3 moles of carbon on the bottom. So 3 moles of carbon on the bottom and 1 mole of TIC on top. So 1 mole of TIC on top. So moles of carbon cancel out. Now I have moles of TIC. So at this point, I am converting moles to kilograms. So I need to convert moles to mass. So I'm going to have to convert it to grams using molar mass. So the molar mass of TIC is the same as before. So I'm using the molar mass again here. So same molar mass. So on the bottom, I have 1 mole of TIC. And then on the top, it's going to be 59.878 grams of TIC. So moles of TIC cancel out. Now I have grams, but I want kilograms. So I'm going to have to use the 1 kilogram is equal to 1,000 grams again. So I'm going to use this conversion again. So then this is going to be 10 to the third or 1,000 grams of TIC on the bottom, and then 1 kilogram of TIC on top. So grams cancels out. Now I have kilograms. Kilograms is what I want. So now again, I can multiply across the top, divide by everything on the bottom, and I get my answer, and that is 831. So this is equal to 831 kilograms of TIC. So here I have 738 kilograms of TIC. Here I have 831. So here, this is the amount of TIC that would be produced if all of this reacted. If all of this reacted, if all of the carbon reacted, it would produce 831. This amount of carbon produces more TIC compared to this amount of TiO2. So that indicates that this is going to run out first before this does, because this is producing less of the TIC, less product. So less product means limiting reagent. Why? Because it's limiting the amount of product that can be formed. And how does it do that? It disappears. It runs out. So this would be my limiting reagent. Carbon would be the agent or reagent that's in excess. So this would be left over after the reaction stops. So now that I figured out the limiting reagent, then I know already, since I calculated it, that this is the maximum amount of product I can form, the TIC. And that, ladies and gentlemen, is how you do a limiting reactant problem. I hope this was insightful. I hope you enjoyed the video. I hope you learned from it. If you learned anything from this video, then please like the video, share the video, hit that like button. Also, make sure you subscribe to my channel. And when you do, make sure you hit the notification bell and click all so you'll be notified by all the videos I put out. And then finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a question you want me to answer, or a problem you want me to go over, or if you have a topic you want me to cover in a future video, I would love to do that for you. Thanks for joining me, and have a great day.